Basic properties of electric charges. Positive positive charges are same type of charges, repel each other. Negative charges repel each other. Positive negative charges attract each other. Opposite charges, same charge, same charge. SI unit of charge is coulomb. Next is electric charge is not a fundamental quantity. As we have studied in class 11th, 7 fundamental quantities like mass, length, etc. So charge is not a fundamental quantity, but electric current is a fundamental quantity. Now it is a scalar quantity. As you know, scalar and vector are those quantities. Scalar is additive in nature, vector is additive but with directions. Scalar do not have directions. Next property of charge is additive in nature, means if a charge is plus 2 coulomb and the second charge is plus 4 coulomb and minus 1 coulomb, then we can add scalarly, means plus 2 plus 4 gives 6 and 6 minus 1 gives 5 coulomb. This is additive in nature. Charge is conserved, means if body A and body B is giving charge to body A, the charge in the system will be conserved. The charge on a particular body changes, but in a system means system having both body A and body B, the charge will be conserved. Next come quantization of charge. As we know, the charge is equal to Q equal to Ne. E is a particular E is a charge of electron, that is 1.6 into 10 to the power minus 19 coulomb, and N is the number of electron. Charge, that is Q, will be in terms of number of electron, means this will be an integer. N will be integer, number of electrons. Therefore charge is quantized. Next comes mass without charge is possible, but charge without mass is not possible. Means if a body has charge, it definitely having some mass, but a body having mass is not necessary to have charge. A body can be neutral also. Next come m is equal to m naught by 1 minus v square by c square. This is a formula of variant mass. Means if a body is moving, the original, means the mass at when the body is at rest is not equal to the mass when object is in dynamic motion. This is a dynamic mass, and this is rest mass. So this is thing that we have studied till now. Next comes Coulomb's law. Force is equal to K into Q1 into Q2 upon में R square. If we have two charges Q1 and Q2. There will be a force existing between two charges. It may be attractive or may be repulsive depending upon the nature of charges. As I have told you earlier that same charges repel each other and the opposite charges attract each other. Therefore, a force exists between them. It may be attractive or it may be repulsive. Let Q1 be positive in nature and Q2 be negative in nature. They will attract. This will be a force on F1, first body due to second body, and force on second body due to first body. These force will be equal in nature. Force is a vector quantity. This is the formula of force. Here Q is constant, depends upon medium. If it is air, its value will be 9 into 10 to the power 9. It can be written as 1 upon 4 pi epsilon naught. Epsilon naught is in air. If another medium is present except of air, it is represented as E dash. E dash can be written as E relative into E naught. E relative is E dash upon E naught. Next comes vector rule. Q1, Q2. Let the distance from the origin of these charged particles be R1, R2 vectorly. Now the force between these two force on 1 due to 2, force on 2 due to 1. R1 is the positional vector of Q1. R2 will be positional vector of Q2. Let the distance between Q1 and Q2 be R. So, force on 2 because of 1 can be written as K Q1 Q2 upon may R square R2 vector minus R1 vector. R2 vector minus R1 vector. Similarly, force on 1 due to 2 equal to K Q1 Q2 upon may R square R1 vector minus R2 vector. As we know, force is equal to mass into acceleration. Question can be asked to find out acceleration also if we have given the mass of body. Next comes principle of superposition. The principle of superposition says that the individual forces between the two charges is independent of the third charge. Means if this charge is q1, this charge is, let's suppose, q2, and this charge is q3, the force on charge q2, initially let's suppose only q1 is present in the system, therefore the force experienced by q2 will be due to q1 only. Now if a charge q3 is present या फिर is also inserted in the system, force on q2 due to q3 will also be experienced, but force due to force due to 3, the net force on q2 will be changed, but the individual force of particle 1 on q2 will not be changed. This is the principle of superposition. Now let us see some questions regarding this concept. A square is given to you, same charge plus q is present at the corners of the square. Now you need to find the net charge on the center of the square if a charge q is present. Now firstly, these charges are same in nature, means a repulsive force will be acting between them, right? Also force is acting between the two charge particles at the line joining these two, means if I have joined this line charge particle with this line, this is the shortest line, the force acting between them will be along this line only, means force this will be force due to this particle, and this force will be due to this particle. Similarly here and here, as we know it is a square, therefore this length will be equal to this length, and this length will be equal to this length. As we know, formula of force between any two charge particle is force is equal to k into q1 into q2 upon my r square. This r is constant, q1 and q2 is constant, k is constant, therefore the force will also be constant. Equal and opposite forces acting between the two charged particles, therefore they nullify their effect. Therefore the F net at the center of the square will be equal to 0. Now let us talk about electric field. Electric field is a vector quantity Here we study about the electric field produced only by the static charges. Means when the charge is not in motion, it is at rest. Next, electric field also known as electrostatic field. Electric field equal to force upon Q naught. Q naught is test charge particle. फोर्स का फॉर्मूला क्या होता है? K इंटू क्यू वन इंटू क्यू टू अपॉन में आर स्क्वायर. इलेक्ट्रिक फील्ड का फॉर्मूला क्या होगा? K इंटू लेट इट बी क्यू नॉट, क्यू वन अपॉन में आर स्क्वायर. राइट. Force will be electric field will be produced due to static charge. Means if this is a charge, let's suppose positive charge, electric field would be produced in this way. Outwardly. If a charge is negative charge, then electric field produced will be in this way. Inward direction. Electric field lines are imaginary lines. Never form a loop. As you can see, this is a positive charge, this is a negative charge. Field lines are produced in this way. Outward from positive, inward from for negative. In this way. They are not forming a loop. As you can see, this is in this direction, S and this. This is not like this and this. This is a loop. Next, density of electric field lines shows strength of electric field. Electric field can be uniform or non-uniform. As I have told you that electric field is a vector quantity. To become it a uniform electric field, it must have a constant direction, means a constant direction and constant magnitude, like this. But in non-uniform, to change a uniform into a non-uniform, there are three ways to change it, like changing a magnitude, changing direction, or changing both direction and magnitude, like this. At every point, the direction is changing tangentially.